Hello guys, I'm Yasir Ali. Today in this tutorial we will discuss about pressure gradient. To understand the topic in a better way, let's first see the background of this topic. This topic is basically related to our previous discussion, that is subsurface pressure, its sources and overburden pressure. As you know that we have started a discussion about the pressure, different type of pressures which we encounter in oil and gas industry. So to understand the concept of pressures in oil and gas industry, we discussed subsurface pressure, then its sources, then overburden pressure. Now continue the same topic, that is formation pressure. We will see this topic, that is pressure gradient. So talking about the definition of pressure gradient, it is defined as the rate of increase in pressure per unit vertical depth, that is PSI per foot. What does it mean? Let's try to understand with the help of this table. In this table we have the depth, pressure and increment. So in the first column, in the depth, we have the depth, starting depth 0, and at the 0 depth we have the 0 pressure. Then our depth has been increased from 0 to 1000 and pressure has been increased from 0 to 433 psi. So how much pressure has been increased? 433. And how much depth increase? 1000. It means for increase of 1000 feet of depth, the pressure is increased 433. Then our depth has been increased from 1000 to 2000 and pressure has been increased from 433 to 866. So how much increase? 433. It means again for 1000 the increase is 433. So similarly from 2000 to 3000, 3000 to 4000, 4000 to 5000, for each 1000 our pressure has been increased equal to 433. Now if we want to see the increase for 1 foot, what we'll do? We'll divide simply this 433 with 1000. So our answer will be 0.433. So what is this 0.433? This is the increase in pressure for 1 foot. So increase in pressure for 1 foot is basically pressure gradient. Now if we read this definition, we will be clarified about pressure gradient, that a pressure gradient is the rate of increase in pressure per unit vertical depth, and here our unit depth is 1 foot. That is, when we increase the depth in a well from 1 foot to the 2 foot, then the increase in pressure for 1 foot, that is pressure gradient. Okay. So this pressure gradient is indicated in oil and gas industry in the form of this chart. In this chart, on the vertical axis we have depth, and in the horizontal axis, that is x-axis, we have pressure. So as you can see, when the depth is increasing from 0 to 5000, here the pressure is increasing, okay, and it is indicated by a linear line. When the depth is 1000, we have pressure 433, then the depth is 2000 and our pressure is 866. So the depth is increasing, then accordingly pressure is increasing. So this trend of the depth versus pressure is shown with the help of this graph, and this graph is known as pressure gradient graph. And what is pressure gradient? It is the increase in pressure for 1 foot of depth is called pressure gradient. Now we'll further understand this topic, that is pressure gradient, with the help of this example. Here the example is hydrostatic pressure exerted by a column of fluid of 1000 foot is 433 psi. What will be the hydrostatic pressure gradient? So simply we have learned that pressure gradient is pressure per foot, and here the pressure is 433 psi. Okay, and how much vertical depth? 1000. So to calculate the gradient, we will just divide this pressure with depth. We will get pressure for 1 foot. So this 0.433 psi per foot is the pressure gradient in this example. Some key concepts associated with pressure gradient. We just discussed the example of hydrostatic pressure gradient. However, in oil and gas industry, we have different type of pressure gradient, like pore pressure gradient, hydrostatic pressure gradient, overburden pressure gradient, fracture pressure gradient and mud gradient. In this particular tutorial, we discussed a general term, pressure gradient, but in oil and gas industry we will come across different types of gradient that I just mentioned. pore pressure gradient, hydrostatic pressure gradient, overburden pressure gradient, fracture gradient and mud gradient, etc. Talking about the formula of pressure gradient, we have discussed in our tutorial of hydrostatic pressure that the formula for the hydrostatic pressure is 0.052 into rho into h. This rho is density and h is the vertical height of the well bore. So this is the formula for the hydrostatic pressure. Okay, so if we just rearrange this formula, okay, so we know the hydrostatic pressure gradient is pressure per unit depth. So if I divide this pressure with depth, hydrostatic pressure with depth, it will be 0.052 into density. So our pressure gradient will be equal to 0.052 into density. Simply, what does it mean? If you want to calculate the pressure gradient due to a certain fluid, so what you have to do, you have to just multiply 0.052, that is the conversion factor, with the density of that fluid. It is explained over here with the help of this example. It is mentioned that calculate the pressure gradient of fresh water, and the density of fresh water is 8.334 ppg. We have just see the formula, it is 0.052 into density, and the density is 8.334. So we will multiply this 0.052 with the density, that is 8.334. We will get 0.433 psi per feet. Okay, so this is the second way to calculate the gradient. The first way we calculated, just divide the total pressure with the total depth, we will get gradient. Second thing, if you have the density of the fluid, just multiply the density with the 0.052, we will get the pressure gradient. Finding pressure using pressure gradient. Okay, we see that if we have pressure and depth, how to calculate gradient. Now we'll do the reverse calculation, that if we have the gradient, how we'll calculate the pressure. So for the example, that hydrostatic pressure gradient for a given fluid column is 0.433 psi per foot. What will be the pressure of fluid column if its height is 1000 feet? So simply reverse calculation. For 1 foot it is 0.433, and for 1000 we'll just multiply this pressure gradient with this depth. That is, hydrostatic pressure is equal to 0.433 into 1000, that is 433. This 0 is just a calculation error, so it will be 433 psi. So if we just summarize, what we have learned is that we learn the pressure gradient. Then how to calculate pressure gradient, we will learn two ways, that if we have the pressure and depth, we divide the pressure with the depth, we will get the pressure gradient. Then we see that if we have the density of a fluid and we want to calculate the pressure gradient, we will multiply 0.052 with the density of the fluid, then we will get the pressure gradient. Now number third, we learned that how to convert the gradient into pressure. So if we have the pressure gradient for a particular formation or a particular fluid column, we'll just multiply with the depth, then we will get the pressure. So these calculations, this interconversion is required during the operation multiple times. So we need to be very clarified about these basic calculations. Something we have already discussed. So that was the discussion about hydrostatic pressure. We will continue our discussion about pressure in more detail in our upcoming tutorial. So thank you very much.